Hello, and welcome to today's video on geometric series partial sums. This video has two objectives. First, that students will understand how to derive the formula for summing the terms of a geometric sequence. And secondly, students will be able to apply the formula to add the terms of a geometric sequence, including word problem applications. As a footnote, this video does not address the sum of all the terms of a geometric sequence, in other words, the infinitely many terms, such as typically addressed in a pre-calculus or calculus class. Look for a video on that topic by me in the days to come. To set the stage, suppose you wanted to add the first 75 terms of the following geometric sequence, a sequence that progresses from 125 to 100 to 80, etc. Incidentally, the value of r there is 0.8. Is there an easier way than calculating each of the first 75 terms and then adding them all up? This method would require a massive amount of inputting into a calculator and be prone to error. Well, great news. There's a way easier method, and it involves a formula that gets the job done with very little effort on your part, and that's what this video is about. The formula to add up the first n terms of a geometric sequence, and it must be a geometric sequence, is S sub n equals the quantity a sub 1 minus a sub 1 times r to the n divided by 1 minus r, where r cannot equal 1. Otherwise, the fraction will be undefined. So how do we get this formula? Where did it come from? Well, first of all, S sub n is simply the sum of the first n terms in any sequence. It could be arithmetic, geometric, or anything else for that matter. So S sub n would be a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub n. We'll call that equation 1. If it's a geometric sequence, then a sub 1 would remain a sub 1, but a sub 2 from equation 1 could be replaced with a sub 1 times r to the first in equation 2. A sub 3 could be replaced with a sub 1 times r squared, and on down the line until eventually the last term in equation 1, a sub n, would become a sub 1 times r to the n minus 1 as the last term in equation 2. Next, I want to multiply every term in equation 2 by a negative r. So the left-hand side will become negative r times s sub n. But the right-hand side, the first term in equation 2, a sub 1, would now become negative a sub 1 times r as my first term in equation 3. My second term in equation 2, a sub 1 times r to the first, would now become negative a sub 1 times r squared, and so on, all the way down the line, until eventually the last term in equation 2, a sub 1 times r to the n minus 1, would become negative a sub 1 times r to the n in equation 3. Now what I would like to do is add equations 2 and 3 and combine the like terms. Well, you'll notice the second term in equation 2 cancels with the first term in equation 3. And if you look further down the line, you'll see terms continue to cancel. The third term in equation 2 will cancel with the second term in equation 3, and so on. Eventually, the last term in equation 2 cancels with the next to last term in equation 3. So the sum telescopes, where all the middle terms cancel each other out. What I'll be left with is on the left-hand side, s sub n minus r times s sub n. But on the right-hand side, I'll be left with the first term from equation 2, which is a sub 1, and the last term from equation 3, which is minus a sub 1 times r to the n. We'll call that equation 4. If I take equation 4 and factor out s sub n, I get equation 5. And the point of doing that is now I could get s sub n by itself if I divide each side by 1 minus r. And that gives me my formula that I was seeking. S sub n equals the quantity a sub 1 minus a sub 1 times r to the n divided by the quantity 1 minus r. This formula is given to you on the Common Core Algebra 2 Regents Exam reference sheet. I prefer factoring out the a sub 1 in the numerator, but they did not on the Algebra 2 Common Core reference sheet, so I'm leaving it as you'll see it on that reference sheet. So for an example, let's say we wanted to find the sum of the first 6 terms of the geometric sequence 5, 15, 45. You'll notice we multiply by 3 to get from one term to the next, so that's my value of r, the common ratio. I'm going to do this problem 2 different ways. In the first method, I'm going to find the next 3 terms, which will be a sub 4, 5, and 6. A sub 4 would be 45, which is a sub 3, times r, which is 3, and that's 135. A sub 5, I could take a sub 4 and multiply by 3, 405, and a sub 6, take a sub 5 and multiply by 3, and I get 1,215. Now I simply add up the 6 terms that I found, the 3 that were given to me, and a sub 4, 5, and 6 that I ended up calculating, and getting a grand total of 1,820. Method 2 involves applying the formula S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. But this time n is 6 since I want to get the sum of the first 6 terms. A sub 1 of course is 5 because it's the first term, and r is 3. Plugging into the formula, and be careful if you're entering this into a calculator. You need to make sure that you put both the numerator in a parenthesis as well as the denominator. You'll get 1,820, which confirms the result from method 1. For a word problem or application, let's take a look at this problem. In 2019, Company A paid $2,637,000 in payroll and $456,300 for employees' health insurance. If payroll is expected to increase by 2.5% per year, and health insurance costs are expected to rise 6% per year, how much should the company expect to spend on payroll and health insurance over the time period from 2019 to 2026? Well, first, we'll let a sub 1 denote the year 2019. Then it would require a sub 8 to represent the year 2026. Now that's important. How did I get that? Well, since 2026 is my last year, minus 2019, my first year, gives me a difference of 7. I want to make sure my subscripts also have a difference of 7. So if a sub 1 is my first year, add 7 to the subscript, and that gives me a sub 8 as my last term. That way there's one subscript for each year in the time period from 2019 to 2026. Now I want to find the total expenditures, hence S sub 8. Payroll, as you can see, a sub 1 minus a sub 1 times r to the 8th over 1 minus r. Now let me pause for just a moment and explain where r comes from. Since payroll is increasing by 2.5% per year, start with a base of 100%. Increase it 2.5%. So 100% plus 2.5% is 102.5%. Converted to a decimal is 1.025, and that's my value of r. So payroll will be approximately $23 million over that time period. Health insurance is a sub 1 minus a sub 1 times r to the 8th over 1 minus r. And what you'll notice here is r is 1.06. And I got that by taking 100%, adding 6% for the increase. 106% converted to a decimal is 1.06. So health insurance, they'll spend about $4.5 million over the 8-year window. Hence, total payroll plus insurance will be $27,553,353, give or take. Another example. Suppose a geometric sequence has 20 as its first term, and each term is 5% less than the previous term. What is the least number of terms n needed such that the sum of the first n terms, S sub n, is greater than or equal to 350? Well, take your S sub n formula and set it greater than or equal to 350. A sub 1 is known to be 20. R, you'll notice I replaced with 0.95. Because each term is 5% less than the previous term, I took 100%, subtracted 5%, giving me 95%, converted to a decimal is 0.95. We're seeking n. n is what we don't know. We don't know how many terms it's going to take, and that's what we're asked to find out. So the first thing I'm doing is replacing the inequality temporarily with an equal sign. So if I take the equation and multiply each side by 0.05, that will get rid of the denominator on the left-hand side. Next, if you just focus on the red part, I would have 20 minus 20 times 0.95 to the n equals 17.5. But then I'm subtracting 20 from each side to cancel out the 20 on the left-hand side. So now I would have negative 20 times 0.95 to the n equals negative 2.5. And now I'm dividing each side by negative 20 to cancel out the negative 20 on the left-hand side, leaving me with 0.95 to the n equals 0.125. Because I don't know the exponent, here's where I'm going to log each side and use the power rule in order to bring the exponent n out in front of the log. So I now have the equation n log 0.95 equals log of 0.125. When I divide off the log of 0.95, I get n to be 40.54. Since n is a subscript, it should be a counting number, so I can't leave it 40.54, so I have to round it. And in this case, I'm going to round up no matter what the decimal would be, because I wanted the terms to be at least 350 for the sum. So n would have to be greater than or equal to 41. So therefore, n equals 41, or it would take 41 terms in order to get the sum to break the 350 mark. By the way, the answer to the question posed at the start of this video, the sum of the first 75 terms of the geometric sequence 125, 180, etc., is 624.9999663. Why don't you use the S sub n formula and see if you agree. I'm Murray Wright, and once again, thanks for watching. Bye.